Day 12.
Okay, for number 1, let's take a look at part C. This here is the opposite of that. X minus 3 and 3 minus x. Like, for example, 8 minus 5 is equal to 3. 5 minus 8 is equal to negative 3. When you subtract backward, you get the opposite. Then if you look at the bottom, this is a positive x and a positive 4. This is a negative x and a negative 4. So those are opposites as well. So if you have the opposite on top and the opposite on bottom, you get back to the original. So number 1 is C. Let's look at number 2. Number 2, you have an x plus 3 on the top. Let's see. Okay, so here you have the opposite on top because that's a negative x. Oh, wait a minute. I need a negative x and a positive 3. So let's look at part D. A negative x and a positive 3, that's the opposite on top. And then a positive x and a negative 4, but I have a negative x and a positive 4. That's the opposite on the bottom. So opposite on top and on the bottom brings me back to the original. So number 2 is D. Okay, number 3. Okay, number 1. Here we have x minus 3 on the top. And what I'm looking for is the opposite of that. And as I look through here, 3 minus x is the opposite of x minus 3. In other words, if you look at the x in the top of this one, it's positive. Here it's negative. Here the 3 is negative. Here it's positive. So those are opposites. So I'm looking now for the opposite on the bottom. This is a positive x and a positive 4. Well, this is a negative x and a negative 4. So those are x's that are positive. Oops. Okay, for number 1, here we have a positive x and a negative 3. This is a negative x and a positive 3, so those are opposites of each other. On the bottom, we have a positive x and a positive 4. Here we have a negative x and a negative 4. Those are opposites of each other. When you have the opposite on the top and on the bottom of the fraction, that's the same thing as the original fraction. So 1 is C. Now let's look at number 2. Number 2, I'm going to erase this stuff. We have a positive x and a positive 3 on the top. And here we have a negative x and a negative 3. Those are opposites of each other. On the bottom, we have a positive x and a negative 4. Here we have a negative x and a positive 4. So those are opposites of each other. So an opposite over an opposite is the same as the original. So this must be A. Okay. Number 3. Let's use a different color. So up top we have a positive x and a negative 3. So when I'm looking at the opposite of that, here we have a negative x and a positive 3. Now in the denominator, we have a positive x and a negative 4. Here we have a negative x and a positive 4. So we have, again, an opposite on the top and an opposite on the bottom. So those are the same. So this, number 3, must be D. I'm working in weird colors. Number 4. Okay. Number 4, we have a positive x and a positive 3. So let's look for something that's the opposite. A positive x and a positive 3, the opposite would be a negative x and a negative 3. In the denominator, we have a positive x and a positive 4. Here we have a negative x and a negative 4. Opposite over opposite is the same, so 4 must be B. Number 5. Here we have a 3 minus x, so a positive 3 and a negative x. Here we have an x minus 3. So a positive x and a negative 3. So those are opposites. In the denominator of the original, we have both positive x and positive 4. And this one, we have a negative x and negative 4. So those are opposites of each other. So this must be E. And finally, number 6. Well, 6 must be the only thing left over, but let's just double check. A positive x and a positive 3, the opposite is a negative x and a negative 3. Here in the denominator, we have a positive 4 and a negative x. Here we have a negative 4 and a positive x. That's the opposite. So this must be F. Okay, they're asking you to do two things. First, they're asking you to list all the numbers that are not in the domain, and then they want you to list the actual domain. Well, x could be anything, almost. X could not be anything that would make the denominator of this fraction equal to 0. So if x were equal to 7, we would have a 7 minus 7 or a 0 in the denominator, and that's not allowed. So the only number not in the domain is a 7. The way to write the domain is you would simply write x cannot be equal to 7. This implies that x could be anything. It just can't be 7. We don't know what x is, we just know what it's not. Okay, again, when we're thinking about the domain, in this problem, we're really only worried about the denominator. X could be anything except something that makes the denominator equal to 0. So 7x plus 1 cannot be equal to 0. That means that 7x cannot be equal to negative 1. So x cannot be equal to negative 1/7. This is the domain. The other thing they wanted you to list in this problem is what are the values that are not allowed? Negative 1/7. So that is the domain. Okay, again, we're only worried about the denominator, and the domain is that this x cannot be equal to 0. That's the domain. Listing the values, 0 is the value that cannot be in the domain. This is the actual domain. Okay, when we're finding the domain, we're worried that the denominator cannot be equal to 0. So let's start there. 2x squared plus x minus 6 cannot be equal to 0. I'm going to factor this. So I have 2x and x. I'm trying to get to a 1. So it looks like a positive 2. That gives me a 4x in the outer minus 3. That gives me a negative 3x in the inner. So this tells me that x cannot be equal to positive 3/2 and negative 2. That's the domain. It asks you to list the values that cannot be in the domain, and so it's 3/2 and negative 2. It's kind of asking the same thing twice. I'm not sure why it's asking you to do it twice like that. Okay, when you're talking about the domain in a problem like this, we're worried that the denominator should not be 0 so that you don't get an undefined. But 14 does not depend on x. So there is no value that x cannot be. So the domain is all real numbers. So we write it in interval notation, negative infinity to infinity. That's the domain. What values are not allowed? None. In other words, we're allowed all values for x. Okay, so when I'm thinking about the domain, I want to make sure that 3x squared plus 8 cannot be equal to 0. That means that 3x squared cannot be equal to a negative 8. Or in other words, x squared cannot be equal to a negative 8/3. Well, I know that's true. That's always true for any x because anything squared is always 0 or positive. That's a negative. I could have identified that right from here, but I took a few steps to really prove it to myself. Okay? So the domain for this is all real numbers. And what values are not allowed in the domain? None. Okay, so for number 21, they're asking for the two terms, not the two factors, but the two terms. And remember, terms are separated by a plus or a minus. So part A, the two terms, one of them is x squared, the other is 4x. For part B, the two terms, one of them is x, the other one is 4. So, I'm not for part B, but that was for the two terms in the numerator and the two terms in the denominator. Okay, for part B, it says describe the steps you would use to write this rational expression in lowest terms. Well, in the numerator, I have a common factor within my two terms, and it's x. So I'm going to factor out the numerator. And in the denominator, I don't have anything in common, but this entire item can be treated like a factor because it's like a 1 times that. And I cancel those, and I have x over 1. So when I reduce this, I get to just x, because I'm factoring out the common factor in the numerator and then canceling my common factor from the numerator to the denominator. Okay, only one of these can be simplified. This cannot be simplified because there is no common factor in the x squared and the 2. So we can, and you remember, you cannot cancel terms. Like this and this cannot be canceled because those are terms. They are not factors. Part B cannot be simplified either because there is no common factor in the numerator, and these are terms. Terms cannot be canceled, so you cannot cancel there. Part C cannot be canceled because there is no common factor in the numerator. These are terms. Terms cannot be canceled, so you can't cancel there. But for part D, we can factor. We can factor the numerator as x times x minus 5. And then we have a common factor in both the numerator and the denominator, and the factors can be canceled. So you can simplify part D, and that's the only one that can be simplified. And again, it just simplifies down to x minus 5. Okay, part A is equivalent because this is the opposite. Notice that when you flip numbers around a negative, you have an opposite. And this is an opposite as well, because here the x is positive, here it's negative, and the 4 is positive up there but negative down there. So this A is equivalent, so that's not going to be that choice. Part B, this is not equivalent. You cannot simply change one of the signs and think that it's the opposite. So part B is what we're after. Okay. Part C, notice that the top is the opposite, but that's taken care of by that negative. The bottom part, the denominator, is identical to this up here. So, but this negative takes care of the fact that there's the opposite up top. So it wasn't C. And finally, part D, this is identical up in the numerator, but this is the opposite, but that negative takes care of that opposite. So part D is also equivalent. Part B was the only one that was not equivalent. Okay, for something to be equal to -1, we have to have opposites on the top and on the bottom. So these are not opposites on the top and bottom, so it's not that. Part B, these are not opposites, they're the same. So this would have been equal to 1. For part B, we have 2x minus 3 and a negative 2x plus 3. These are opposites. So this is going to divide out to -1. And finally, we have a positive 2x and a positive 3, and a negative 2x and a negative 3. Those are opposites. So this is also going to divide out to -1. So B and D will divide out to -1. Okay, so we're going to cancel common factors in the numerator and the denominator. So this entire x plus 1 factor gets canceled. One of these x's will get canceled there, and so we'll be left with just x over 1, which is just x. Okay, for number 26, we'll cancel the common y minus 4. That's going to go away. And we'll cancel 2 of these y's down here with 2 of them there, making that a y to the 1. We don't ever write a y to the 1 power, we just write y. Okay, we have a common factor of x plus 4 on the top and bottom, so that cancels. And when we rewrite this, we have to get rid of those parentheses because a division bar implies parentheses. So putting the parentheses would mean that we have redundant parentheses, which is not simplified. So our final answer is just going to be x minus 3 without parentheses over x minus 5 without parentheses. Okay, when we start canceling, we say 4 goes into 4 once, but into 8 twice. And we cancel one of these x's up here with one of them over there. We cannot cancel x plus 3 and x minus 3 because they're not opposites or anything like that. So now we just have an x plus 3 on the top. Notice I removed the parentheses because they would be redundant. And on the bottom, we have a 2x and an x. A 2x and an x minus 3 on the bottom. Notice these x's cannot cancel because this is a factor and this is part of a term. You cannot cancel, you have to cancel an entire factor. So this is the final answer. Okay, this problem is already in lowest terms. These 3's cannot cancel because that's a factor all by itself, but this is part of a term. So those cannot be canceled. You can only cancel complete factors. So we're done. In order to cancel, we have to be thinking about factors. So we have to start by factoring this. We'll take a 6 out of the top, and it leaves behind an m plus 3. We'll take a 7 out of the bottom, and it leaves behind an m plus 3. These are now common factors that can be canceled from the top to bottom, so our final answer is going to be 6 over 7. Okay, in order to cancel, we first have to factor so that we can cancel factors. We have a common z on the top. It leaves behind a 3z plus 1. We have a 6 common on the bottom, and it leaves behind a 3z plus 1. And now we can see that there's a common 3z plus 1 factor on the top and bottom, which will cancel, and we're left with z over 6 as a final answer. Okay, so again, we're going to factor. Up top, we have a GCF of 2, so we pull that out, and it leaves behind a t plus 3. On the bottom, we have the difference of 2 squares, so we get the conjugate pairs, which is t plus 3 and t minus 3. And now we can see that we have a common t plus 3 factor on both the top and the bottom, so those cancel, and we're left with 2 on the top and t minus 3 on the bottom. Okay, in a problem like this, be careful not to try to cancel something in the form that it's in, because right now those are all terms and you cannot cancel terms. You can only cancel factors. So we're going to have to factor. Up top, we have a binomial times a binomial, and it looks like x and x. We're trying to get to 2, so plus 5 and minus 3. On the bottom, we have x and x, and we're trying to get to 6, so plus 5 and plus 1. Now we can see that we have a common factor of x plus 5 in the top and bottom. And when we write our final answer, those parentheses are now redundant, so don't include them in your final answer. We write x minus 3 on top and x plus 1 on the bottom. If you wrote the parentheses, that's an unsimplified because the parentheses are already implied on the top and bottom of a fraction bar. Okay, so I'm going to factor the top. I'm guessing that it's going to be a 4x and a 2x. I might be wrong, and I might have to go back and undo that. But that's what I'm guessing. I'm trying to get to negative 10 through subtraction. So if I put my negative 3 here, that gives me a negative 12 on the outside. A plus 1 gives me a positive 2 on the inside, and that gives me to my negative 10. So that works. So on the bottom, I believe I'm going to do the same thing. So 4x and 2x. This time I'm trying to get to a 6. So let's see, 3 and 3. So 3 here gives me 12 on the outside. 3 here gives me 6 on the inside, and that subtracts to 6. So negative there gives me a negative 12 on the outside. A positive 3 gives me a positive 6 on the inside, and that brings me to my negative 6. All right. So now I can see that I have a common factor of 2x minus 3 on the top and bottom. So my final answer, and again I'm going to eliminate my parentheses, is 4x plus 1 over 4x plus 3. Okay, so in the numerator of this problem we have the sum of two cubes. Remember, that's always going to be a binomial times a trinomial. And we do put the cube root items in the binomial. For the trinomial, we go square, product, square. So the square, the product of the two, and the square of the last. And then we do SOAP. This is a plus. Same, opposite, always positive. Over A plus B. Now this entire factor cancels with this entire factor. And we're left with, without any parentheses because they would be redundant, A squared minus AB plus B squared. Okay, here we're going to start by factoring a 2 out of the numerator, and we'll be left with C squared plus CD minus 30D squared. And the denominator will factor out a 2, and we'll be left with C squared minus 6CD plus 5D squared. And right off the bat, those 2's can cancel. And then I'm going to factor out what's left on top. So we have a leading coefficient of C, so that's just going to be of C squared, so that'll be C and C. We're trying to get to 1. So plus 6D minus 5D. That'll do it on top. On the bottom, we have C and C. We're trying to get to negative 6. So negative 5D minus 1D, and that'll get us to negative 6. Okay, we have a common factor of C minus 5D on the top and bottom, so that cancels, and we're left with C plus 6D on top. Notice I got rid of the parentheses because they would be redundant, and C minus D on the bottom. To be clear, we cannot cancel those C's or those D's because those are terms, and you cannot cancel terms. You can only cancel entire factors. So that's the final answer. Okay, in the numerator, I'm going to factor by grouping. I'll group these two together and pull out an A. So I'll have A times C minus D. And then I'll leave a big space and I'll put C minus D again, and then think about what I'd have to put in front, so I multiply back to those. And it looks like a positive B. So I'll put a plus B. Okay? Continuing to factor the top, now I have a common C minus D, so that comes out, and I'm left with A plus B. So that's the complete factored numerator. Now let's do the same thing to the denominator. I'll look at just these two here, and I have a common A. So I pull out the A, and I'm left with C minus D. So I'm going to leave a big space, and I'll put C minus D again, because I know it has to be identical. Then I think about what I'd have to put in front, so I get back to these. And it looks like a minus B this time. Okay? And so now I can see that I have a common C minus D, so that goes out front, and I'm left with A minus B. So now when I look at this, I have a common C minus D factor that cancels, And I'm left with a plus b in the numerator and a minus b in the denominator. A couple of things. Don't put parentheses because those would be redundant and not simplified. And the second thing is I cannot cancel those a's because those are terms. Same with the b's. So this is a completely simplified answer. Whenever you're subtracting backward, you can always cancel by introducing a -1. Now, that's the shortcut. You could have, if you wanted to, factored out a -1 up top, and you'd be left with a b minus 7. Notice when you multiply this in, you get a -b, which you had, and you get a positive 7, which you had. And then on the bottom, you have b minus 7. But this is way more work than you needed to do. Whenever you're dividing and you have a factor that's backward around a negative sign, they can just cancel as long as you introduce a -1. Okay, in the numerator, we have the difference of two squares, so we end up with x plus y times x minus y. In the denominator, we have a y minus x. Now remember, when you're subtracting backward, you can simply cancel as long as you introduce a negative sign. And so when I distribute that negative into those parentheses, I'm going to end up with -x minus y. And that will be the final answer. Okay, here we have an a minus 3 in the numerator and a 3 minus a. These can cancel as long as you introduce a negative. So your final answer is simply going to be negative. Now I'm going to get rid of the parentheses because they would be redundant over x minus y in the denominator. And you're done. Okay, I'm going to factor out a 5 in the numerator, and I'll be left with k minus 2. In the denominator, I'm going to factor out a 10, and I'll be left with 2 minus k. So the first thing, notice I can cancel these as long as I introduce a negative sign. And then I cancel the 5 and the 10. This goes into this twice, so I'm going to end up with -1 over 2. Okay, in a problem like this, as long as it's being multiplied, anything in the numerator, it doesn't matter which fraction it is in, can cancel with anything in the denominator. So this x plus 2 can cancel with that x plus 2. This x plus 1 can cancel with that x plus 1. This x plus 3 can cancel with that x plus 3. And now all I'm left with is x plus 4 in the numerator. So I have, let's do it. I have x plus 4 in the numerator, and I have x minus 2 in the denominator. Again, I got rid of the parentheses because they would be redundant. I cannot cancel those x's because they are terms and not factors. Same thing with the 4 and the 2. So this is my final answer. Okay, remember, a division, you can simply change it to a multiplication by flipping over the second fraction. So I'm going to rewrite this as 2x plus 3 times x minus 4 over x plus 8, x minus 4. And I'll change this to a multiplication, and now this goes on top. X minus 4, x plus 8. On the bottom, I have x minus 4, x plus 2, and now I can cancel anything from the top to anything with the bottom. So for example, x minus 4s, those will cancel. These x minus 4s will cancel. And it didn't matter which one you canceled, anything from top with anything on the bottom. These x plus 8s cancel. And that's it. That's all you can cancel. So my final answer is going to be 2x plus 3 over x plus 2. And I don't have the parentheses because they would be redundant. I cannot cancel those two x's because those are terms at this point and not factors. So that's my final answer. Okay, so I know a couple of things. I know I'm going to have to factor in order to cancel. I also know I'm going to change this to a multiplication by flipping the second fraction upside down. So let's factor the top left. I take out a 7, and I'm left with t plus 1. I change this to a multiplication, and now I'm going to factor this, but I'm going to put that in the denominator. So I have a 4t plus 1. Okay, now let's start canceling. T plus 1 cancels. I'm going to divide by 3. 3 goes into 6 2 times and into 15 5 times. So now I'm going to put my answer back together by multiplying across the top, and I get 5 times 7 is 35. I multiply across the bottom. 2 times 4 is 8. And instead of putting the negative in the denominator, I'm going to put it out in front of the whole fraction. And I'm done. Okay, so in the denominator, I'm going to factor, and I have I have 4x over 4 times 2x plus 1. In the numerator up on the right, I'm going to factor. I'll take out a 7, and I'll be left with 2x plus 1. Okay, so let's start canceling. Obviously, this entire 2x plus 1 just cancels. And then I can cancel 4 goes into 4 one time, so those cancel. And I can't cancel anything else. So my final answer is going to be 7 times x, which is 7x over 6. Okay, so let's factor the numerator of this one on the top left. So those are the difference of two squares. So I have p plus 5, p minus 5 over 4p times 2 over 5 minus p. Now I can cancel these as long as I introduce a negative. And so I'm going to put the numerator back together. Remember, your monomial factors always come first. So I'll put the 2 out here, p plus 5 over, oh wait, I need to cancel. So these cancel, and that becomes a 2. So up in the numerator, let me erase this. Oops, that becomes a 2. In the numerator, I'm only going to have a p plus 5. And in the denominator, I'll have a 2p. Be careful not to try to cancel those p's, because that p is a term, not a factor, and you can't cancel it. So that's the final answer. Okay, so let's factor the top left. That's a difference of two squares. So m plus 7 times m minus 7 over m plus 1. I'll change this to a multiplication by flipping this upside down. So I'll have m over 7 minus m. And then I can cancel this as long as I introduce that negative sign. Nothing else can cancel. Remember, when you put this back together, you have to put your monomial factor first. So I have negative m times m plus 7 over m plus 1. Okay, so let's factor the top left. I'll take out a 2. And we've got 6x minus 5y. I'll leave the bottom. That cannot be factored. I'll take a 2 out of the top right, and I'll have 3x plus 2y. And I'll take a 2 out of the bottom, and I'll have 5y minus 6x. Okay, so now I can cancel one of these 2's right off the bat. I can cancel an entire 3x plus 2y. That cancels. And finally, I can cancel 5y minus 6x with 6x minus 5y as long as I introduce a negative sign. So my final answer is going to be just negative 2. And I'm done. Okay, so let's factor the top left. We've got x plus 5, x minus 5, since that's the difference of two squares. On the bottom, we have x plus 5, x minus 4. On the top right, we've got x plus 4, x plus 3. And on the bottom right, we have, let's see, x minus 5, x plus 3. Okay, so let's start canceling. X plus 5s cancel from top to bottom there. X minus 5s cancel there. And x plus 3s cancel there. And we're left with x plus 4 over x minus 4. Don't try to cancel those x's or those 4s because they're terms and not factors. So we're done. Okay, so let's factor up top on the top left. I'm going to guess that it's a 3x and a 2x. And let's see, it's got to be a 3 and a 2. So 3y and 2y. 3 on the outside gives me a positive 9y, xy. And a negative here gives me a negative 4. And that gives me my positive 5. On the bottom left, well, let's do that in a moment. Well, we can do that now. I'm going to guess that it's a 3x and a 4x. I could be wrong. I'm trying to get to 11. So negative 2y, that gives me a negative 8 in the center. And this gives me a negative 3 in the outer, and that adds up to my negative 11. Then I'm going to change this to a multiply by flipping this upside down. So I'll do this, but put that on the bottom. That's a perfect square. This is 2x minus 3y quantity squared. On the top, we're doing this. This is a 4x and a 2x. I'm guessing. I could be wrong. So if I put a minus 3y here, that's a negative 12 on the outside. A negative 1 here, that's a negative 2 on the inside. And that adds up to my negative 14. Okay, so let's start canceling. 3x minus 2y, that cancels with one of those. 4x minus y, that cancels there. Now, 3x minus 2y and 2, oh, excuse me, that's not correct. 2x minus 3y cancels here. And I'm left with 2x plus 3y on the top and 3x minus 2y on the bottom. Okay, so let's start by factoring the top left. I'm going to put 3k and k, and I got to get to 17, so this must be a 5p and a 2p. That'll get me to my 17 from my inner and outer. On the bottom, I'm guessing that it's going to be 3k and 2k. I'm trying to get to 13, so this must be a minus 5p and a plus 1p. That gives me negative 15 plus 2, which is, this must be a plus 5p and a negative p. That gives me a positive 15 minus 2. Okay, I'm going to change this to a multiplication, and this is now going to go on top. So I have 3k and 2k, and I have p and p. So I'll do negative and negative. That's a negative 3 and a negative 2 add up to my negative 5. And then this will go on the bottom. I'll have 3k and 2k, and I have minus p, that's minus 3p on the outside, plus 2p, that's a positive 4pk on the inside. That adds up to my 1. All right, so everything's been factored, okay? And now I'll start canceling. This cancels with that. This cancels with that. And this cancels with that. And so my final answer is k plus 5p over 2k plus 5p. And I'm done. Okay, so let's factor the top left, and this is going to be 3k. I'll put a minus 5 here and a plus. Oh, that doesn't work. Oh, yeah. 3k and a 2k. Okay, so and a plus 1 there. So that gives me minus 15 plus 2. That's good on the top there. Over in the bottom, we'll factor out a k. Then I'm going to change this to a multiplication and flip this upside down. So I'll put my 2k minus 5 on the bottom, and I'll factor out a k, and then I'll be left with, let's see, this is like a k times k squared plus 6k minus 7. So this is going to be a k and a k. I'll have a plus 7 minus 1. And finally, I have this I'll factor as k minus 6, or no, minus 3 minus 2. Minus 3k minus 2 up top. And on the bottom, I'll have a 3k and a k. So it's got to be a minus 3 plus 1. Okay, now I'll start canceling. 3k plus 1 cancels. My k's cancel. I have a k plus 7 that cancels. I'll just do this in blue. I have a k minus 5 and a k minus 5 that cancels. I have a k minus 3 that cancels. And I don't see anything else that can cancel. So my denominator is completely gone, and I'll eliminate that. And in my numerator, I have k minus 1 times k minus 2. It's perfectly acceptable to leave it like this. If you FOILed it out and combined like terms, you'd get k squared minus 2 minus 1 is minus 3k plus 2. That would have been acceptable as well. I would have just left it like that.